Hello and welcome to today's GSA Snapshot webinar. In the next 30 minutes or so, our research team will take a comprehensive look at the continuing emergence of 3GPP standards-based 5G non-terrestrial networks and the partnerships driving it. The on-demand recording of this session will be shared with you immediately following the event. You can also shortly download the presentation. Join this event by moving your mouse over the slides and clicking on the download icon in the top right of the screen. There will be time for questions following the presentation, which itself will be about 15 minutes. So please do submit your questions using the Q&A chat box on the right side of the screen, and the team will answer as many of them as possible. Those which we don't get to, we'll endeavour to answer by email after the event. In the coming minutes, hours later today, we will be publishing the reports that lies behind this data that we're sharing today. And we'll share that link to the reports page with you again after this event. But first, a very quick recap just on GSA. So we now number almost 100 members and associates from across the whole mobile ecosystem. And the work of GSA includes both gathering and sharing data insights and industry advocacy. GSA has focused working groups, including private mobile networks, 6G standardization, spectrum, and the Fixed Wireless Access Forum, which itself has 57 members representing about 80% of the infrastructure, chipset and module and CPE value chain for fixed wireless access. Late this month, we'll also be formally announcing our new GSA RedCap Marketing Special Interest Group. So please look out for news on that in the coming days and how your organization can get involved. In parallel to this advocacy, GSA publishes over 160 reports annually based on data from our Gambods databases. These databases can be accessed by all employees of every GSA member and associate organization via the GSA website, and they contain the most up-to-date global data on 4G and 5G devices, networks, technologies, spectrum, and chipsets. So if your organization is a GSA member or associate, you personally have unlimited access to all this data, and you can use it to create slides and charts to support you in your daily work. If you have any questions on how to use that, please do get in touch with us via the website. But today, the team is focused on 5G non-terrestrial networks and going to be providing you with a comprehensive snapshot of the headline data that you need to guide and inform your business and your product planning in this area. So to that, I'll hand over to Joe Garner and first Luke Pearce from the GSA research team.
Thank you very much. Today we'll be talking about non-terrestrial networks and satellite connectivity, which if you've been following the kind of satellite industry or even generally kind of the mobile and telecoms news, satellite is becoming a much more important theme in the industry, and we'll be covering some of the latest announcements and partnerships that have taken place over the last few weeks and months. So the use of satellites in general is pretty extensive. You know, we're covering a wide range of applications, including TV, broadband, weather, imagery, or many other kind of applications. But today we'll be just focusing on satellite communications. And generally in communications, satellite or non-terrestrial networks, as we'll be referring to them, they've kind of, although they started very similar to the mobile industry, have generally operated quite separately from the mobile communications industry over the last few years. But those two are coming closer together now, back again. So with non-terrestrial networks now integrated into the 3GPP 5G standard, starting with narrowband IoT in release 17 and expanding to NR-NTN in release 18 and beyond. So for this report, we'll be tracking kind of three key use cases which involve partnerships between mobile network operators and satellite vendors. The first of those is kind of broadband, generally kind of the satellite fixed broadband market, generally used for rural connectivity. This service is used to kind of household connectivity and enterprise connectivity as well. While some of these providers directly sell to consumers or businesses like SpaceX Starlink, for instance, or Hughes Networks, there is a growing trend of mobile network operators to resell or wholesale satellite broadband services. So we'll be covering this one in that. And we're seeing lots of low Earth orbit constellations, or LEO constellations, from providers such as SpaceX Starlink, OneWeb, as well as Amazon Kuiper and some of the upcoming Guowang, driving increased availability for satellite broadband. We're also seeing quite a lot of momentum in recent years around direct to cell phone. That's perhaps a slightly newer use case which allows smartphones to connect directly to satellites. There are two main approaches at the moment in the market in terms of how that's happening. One is where that is sharing IMT mobile spectrum with mobile operators, and that's the approach that the likes of SpaceX Starlink and AST Space Mobile are taking. Or there's the approach of using dedicated MSS or mobile satellite spectrum as well, such as what kind of Skylo are doing and partnering with some of those kind of geo satellite operators as well. And finally, we'll be tracking kind of satellite IoT and machine-to-machine, generally enabled by the 3GPP Release 17 narrowband IoT standard. This use case really facilitates roaming between kind of terrestrial and non-terrestrial networks for IoT devices based on that kind of cellular NB-IoT technology. So they're the three that we'll be covering in this presentation today. Generally, it's kind of important to note that we will be quantifying publicly announced satellite partnerships. So just a note that there may be additional agreements that have not been disclosed in the public domain. So just a small caveat there. Also, there are some other satellite use cases, such as satellite backhaul or in-flight connectivity, where mobile operators are involved in as well. But generally, that's outside the scope of this presentation today. So I'll pass you over to Joe now, just to share some thoughts about the market landscape in those three areas. Thanks.
Great, and thank you very much, Luke, and good afternoon, everybody. Satellite technology has really gained impetus in the last year, and satellite broadband is no different. As we can see from the sort of the graph on your screen, satellite broadband is becoming widely adopted across the globe, and this is because traditionally satellite broadband services had higher latency and usage limitations, but now with technology advancements like Lucas just talked about with LEO constellations and improved technologies, this has meant there's faster speeds and larger data packages available, making it a good alternative to fibre or copper broadband. So by mid-March 2025, the GSA has identified 44 countries or territories that are either planning, testing, or have launched services. 34 countries have at least one instance of an operator planning services, with a recent example being in India, where Reliance Jio and Bharti Airtel have agreed deals with Starlink, though it should be noted we are still waiting for regulatory approval. An agreement in India is sort of notable because it can allow the two operators to tap into a market that has a low fibre rollout and a growing need for connectivity. The GSA has also identified 13 partnerships that have launched broadband services or satellite broadband services. This includes in the UK with BT partnering with OneWeb. Though the number of launches are still in their infancy, we can see from the map there's a growing number of investments across the earth, helping connect rural and unconnected areas across the world. If we dive a bit more sort of deeply into satellite broadband partnerships, we can see that there are 68 operators that have partnered with satellite providers. I should quickly re-emphasize the point that Luke made, that we are only tracking sort of reseller partnerships and constellation partnerships. So even though Starlink has D2C offerings in about 120 countries, we don't track them. 48 of the partnerships are planned, with one example includes Orange and Telesat Lightspeed, which was announced around MWC and will be operational in France. And DirecTV is partnering with Project Kuiper in Uruguay. Now, we do expect these numbers to increase over the next few years, and this is in part due to greater competition in the satellite broadband market, as, for example, constellations like Amazon Kuiper will begin to start offering commercial services in roughly the next year or so. There are also a few Chinese constellations, including the Thousand Sails constellation, that will offer new opportunities for operators to partner with. And this should have a sort of downward pressure on prices, making satellite broadband more accessible to sort of the wider world. And then if we then move to sort of the hot topic in satellite, and that is satellite to cell phone or direct to cell phone or direct to device. There's a lot of different names you can choose, and it's gaining a lot of attention. And this is largely due to the capability of connecting the most remote and rural areas that have long struggled with terrestrial networks to help bridge the digital divide with sort of a phone in your pocket, so to speak. Now, one approach for direct to cell phone is with the new LEO or low Earth orbit constellations. Now, most of these satellite providers are using terrestrial spectrum, which is owned by mobile operators, rather than the dedicated MSS spectrum or mobile satellite spectrum. As of March 2025, the GSA has found 7 countries or territories that have launched services, all of which are using terrestrial spectrum. Notably, Link Global was the first to launch, and this was in sort of a few Pacific islands, including the Cook Islands, though we should note that this service is not continuous. However, in recent weeks and months, we've seen sort of some wider scale exciting deployments with T-Mobile and One New Zealand partnering with Starlink to launch services. Now, these only offer basic functions like emergency and SMS messaging, but One New Zealand has reported that so far 10,000 SMS texts are being sent a day, showing a high interest in the technology and its use in rural areas. So, and once again, it's sort of similar to satellite broadband. That is the case, sort of seeing investment across the globe. And if we're looking at that investment across the world, now one partnership in particular is encouraging that, and that is the partnership between AST SpaceMobile and Vodafone, because Vodafone plans to offer the service provided by AST SpaceMobile to its sort of businesses across Europe and Africa. Both the AST and Vodafone also showed an exciting trial recently, which I don't know if many of you saw it, which was in the UK. It was a 5G video call over satellite, showing that satellite to cell phone is moving already sort of kind of beyond SMS capabilities. Now, the partnerships we've talked about so far, so Starlink, Link, and AST SpaceMobile, are all using terrestrial spectrum, but there are partnerships that are using the 3GPP roadmap. And this approach means that you've got to use sort of the latest device, like the Google Pixel 9, because you need a device that can work with sort of mobile satellite spectrum. Now, there's an advantage of using it, as this approach can help circumvent spectrum issues. However, it does mean that sort of limits the use case of the number of people that can use that technology, because it is only the most kind of premium tier smartphones. One example of this service is Skylo partnering with Deutsche Telekom, and this is one of the 16 examples that the GSA has tracked, and Deutsche Telekom and Skylo are hoping to launch the service in Germany by the end of the year. The GSA overall has tracked 34 partnerships that are planning to launch D2C services, which includes STC in Saudi Arabia, Salt in Switzerland, Telstra in Australia, and they're all planning services. Now, this terrestrial approach employed by Starlink, AST, and Link, and the 3GPP approach used by companies like Skylo are kind of two separate things, but we are seeing a bit more of a convergence and a collaboration, which Luke will talk about a bit later on. If we then jump to IoT, or satellite IoT, I should say, and this is, as you can see from the graph, very much in its infancy. By mid-March 2025, the GSA has identified 8 countries with partnerships that are either planning, testing, or have launched satellite IoT services. Of these 8 countries, 5 are currently planning services. This includes Brazil, Spain, the UK, Germany, and Japan. Though we have seen limited rollout of satellite IoT, we expect countries with large manufacturing, mining, agricultural, and distribution industries to utilise the technology in the future, due to the technology's asset tracking and sort of asset control capabilities across sort of large distances. And then finally, if we just dive quickly into satellite IoT a bit more before passing back to Luke, we can see that there are 14 partnerships that the GSA has tracked, so either launched, or trialling, or are in a planning stage. The first of these was to launch was AT&T Mobility, which partnered with Globacom in 2016. Other partnerships include Telefonica, partnering with Sateliot in Spain, And recent examples at MWC, this partnership was announced, was Verizon partnering with Skylo to help extend its domestic coverage. I'll now pass back to Luke, who will talk you through a number of things, including the constellation developments, as well as how the industry is progressing to 3GPP NR NTN.
Thanks very much, Joe. And I'm seeing some questions come in as well, which we will have time for at the end. I hope to address some of those as well. So please keep those coming in, and we can touch more on those in a little while. So as Joe mentioned, we are tracking a variety of different satellite vendors that have announced partnerships with mobile network operators. In terms of who has the most, SpaceX Starlink has the most publicly announced partnerships with 27. That is part in the fact that it's got a foot in both camps, with its involvement in both satellite broadband, but also now direct-to-cell services as well. AST SpaceMobile also has 25 partnerships with mobile operators publicly. I think they have a few more, but they are perhaps not public for the direct-to-cell offering. And as Joe mentioned, MWC, we saw AST really expanding its presence in Europe, backed by its major investor, Vodafone. Link Global has 18 publicly announced partnerships. Again, the actual number is likely to be a bit higher than that. And at the Satellite Show as well, which was held a week after MWC, just a week or so ago, Link Global revealed that it had secured recent funding from SES and Intelsat as well. So that's a very interesting development that came out from that show. In terms of the other constellations, OneWeb, SES, and Project Kuiper have announced several partnerships across the use cases that we're tracking with network operators. And generally in the satellite industry, we have seen several mergers and acquisitions that are reshaping the industry as well. For instance, the Eutelsat OneWeb merger, I think, is now complete. We've also got a pending merger with Intelsat and SES as well, pending approval. And Viasat has also acquired Inmarsat as well. So certainly quite a bit of movement in the satellite industry, as well as these brand new LEO constellations, as Joe was mentioning earlier. So lots happening in terms of the market landscape for satellite constellations and partnerships as well. In terms of where those partnerships in terms of where those vendors, are based, we are kind of seeing how that looks kind of globally. And the United States has the highest number of satellite constellation providers. So 14 of those that we're talking about are based in the US. We are seeing some more in other areas of the world as well. China, as Joe mentioned, have a few high profile ones. The UK has a few as well. And the rest of the providers are spread across various countries in Europe, Africa, and Asia. I would say that, in recent years, constellation sovereignty has become a bit of a key theme. I think particularly satellite networks are playing an increasingly critical role in secure communications, defense, and surveillance as well. So as a result, more countries and regions are investing in new constellations as well. And there's many examples of that. For instance, the European Union's push towards IRIS², which is a kind of European focused constellation that we're seeing as well. So expect more developments in that domain. Looking at kind of frequency bands now, I can see there's a few kind of questions about that coming in around the spectrum. Generally, satellite constellations operate across various frequency bands, many of which are designated for primary satellite use by the ITU. For 5G NTN, it's really the L band and the S band, which were utilized in 3GPP release 17 as part of the FR1, and that's kind of targeting the handheld devices. So about 6 of the satellite providers we're talking about operate in those frequency bands as well. Looking ahead, release 18 introduces the KA band, which has the largest number of satellite providers, and in release 19, the KU band is also a target for the 3GPP 5G NTN standards, which offers greater capacity for satellite communications. So really, as we move forward into the future 3GPP releases, we expect to see more bands being integrated into those kind of 5G NTN standards. But beyond spectrum, the industry is really kind of progressing towards 3GPP NR NTN, which is really the next step from where we are today. And in recent months, there have been kind of 2 noticeable kind of NR NTN trials and demonstrations that are happening in kind of lab-based environments at the moment, but really kind of proving that commercialization is not so far away. For example, the kind of Ericsson, Qualcomm, and Thales successfully demonstrated a 5G standards-based non-terrestrial network call over a simulated LEO satellite channel. That was something that they've been working on since about 2022 and announcing that recent breakthrough at MWC. In a similar vein, kind of MediaTek, Eutelsat Group, and Airbus were working on a trial to do with kind of Earth-moving beam concepts. Again, they were using the Ku and Ka band this time to successfully connect a 5G core to a 5G user terminal via a satellite link, enabling data exchange there as well. So definitely kind of very innovative work going on in laboratory-based environments at the moment. And as we move forward towards that kind of standard, we are seeing more collaboration on NTN standards, where there's several associations and space agencies really driving movement in this market. At MWC, we saw a few more progress in that domain. The European Space Agency taking a bit of a role in this, signing a memorandum of understanding with the ITU, the International Telecommunications Union, and the MSSA as well to support this effort. If you don't know what the MSSA is, it's the Mobile Satellite Services Association. They are gaining quite a lot of momentum over the last recent months. They represent kind of owners of the L and S band, which we mentioned are included in that 3GPP standard. And their whole aim is to align with the standards to drive kind of scale and choice in the mobile satellite ecosystem for kind of direct to cell phone and IoT services as well, where that spectrum is already allocated and licensed for satellite services. But as Joe mentioned, the ecosystem is still developing, so we're expecting more and more devices supporting that, and that some of those devices that support that are included within the report as well. And finally, although kind of 5G NTN does remain a focus, discussions on 6G have also now begun. So the recent 6G workshop in Seoul also kicked off a week or so ago. And big part of 6G is the integration of roaming between non-terrestrial and terrestrial network as a kind of key pillar of future connectivity standards. So this is going to continue to be a big topic that we will continue to track all the kind of ongoing developments here as well. Great, I think that's all the content we had time for today. I think we've got a couple more minutes perhaps to move on to some questions, if there are many, which there seems to be quite a few. Okay, so yeah, quite a few questions coming in. Where shall we start, Joe? Have you seen any of that?
Yeah, so I saw a question on the issue of cross-border interference, and then link it to a different one on sort of the best approach for Europe. And I think that's a very astute kind of point, really, because in Europe, obviously, sort of it's a geographically very enclosed area, with lots of different spectrum rules, spectrum allocation, that there will be spectrum interference issues. So that's where regulators, operators, constellations will need to work together. I think one example of, this is the approach using sort of terrestrial spectrum, and I think maybe a sign that operators are maybe more keen to go through to the SS spectrum approach is that Deutsche Telekom has a subsidiary with T-Mobile, sort of the flagship partnership. And T-Mobile went with Starlink, where Deutsche Telekom is going with Skylo. So that possibly suggests that maybe Europe is looking to go in sort of that approach, but equally, then obviously Vodafone has that partnership with AST SpaceMobile. So I think it will be really interesting. I think it will all be about collaboration, and it will probably just mean a sort of a slower rollout of services. SOS, SMS capabilities, that probably will be possible, and to be able to avoid spectrum interference. But when you get into sort of the more exciting use cases like voice and data, I think that's possibly where, you'll just need more collaboration and possibly lots of exclusion zones around certain areas, so there isn't cross-border interference or interference in big cities that you sort of find in Europe.
Thanks, Joe. Yeah, good one. We got a question here about why satellite to cell when using kind of the IMT approach is not available in all handsets in certain countries. So, kind of highlight an example that in New Zealand, the service is only limited to certain amount of smartphone models, and I think that's a good question. With that IMT approach, the promise from these constellations is that the ecosystem is already there. They can support any unmodified smartphone connected to that network. But as the question rightly highlights, that hasn't been the case so far in these early deployments. I think my impression is that those devices are having to be tested and verified on the network before that before that kind of feature is enabled. So that's why we're seeing it kind of trickled quite slowly through those different devices as well. So it's less of a kind of a hardware limitation, but more of a kind of verification check and regulation being approved on each of those devices, device by device. So yeah, I think the New Zealand example, the list of device supports is continuing to grow as well day by day as they kind of verify and check each of those devices. Any other questions, Joe, that we can answer in the time remaining? There's obviously a few about kind of highlighting certain kind of clarifications with the report, so we can get back to those. I think in kind of email following the call as well. In terms of, there's a few questions about kind of frequency bands of kind of Starlink and AST Space Mobile. So yeah, although they are using IMT spectrum, they do have kind of preferred spectrum bands that they will leverage off telephone operators. I believe most of them are kind of sub 3 gigahertz. Isn't that right, Joe? I think I can't remember quite the specific ones, but yeah, AST Space Mobile I think is maybe sub 1 gigahertz that they are preferring to use, and I think SpaceX Starlink is sub 3 as well. So yeah.
Yeah. And there's a question here on can you please explain how voice NTN discussion is possible with latency due to satellite? Are there any new technologies available? I think when you're looking for the MSS approach, I think Skylo does plan to offer voice calls eventually, because it's a sort of network infrastructure and architecture in reducing that latency. Obviously, historically, that has been sort of the main problem. But I think that's going to become sort of a normality over the next couple of years, both in MSS and then I think terrestrial networks already have that capability. It's more just getting it through the testing and then approval process.
Yeah, I think with low Earth orbit satellites, the latency is much better than geostationary as well. So yeah, there is a need for kind of more LEO satellites to enable more features such as that as well. There's a question here about the kind of ecosystem approach. So for kind of the widespread adoption of L-band on Android and Apple devices, and whether it's possible for an existing handset to use new frequencies with software updates, or whether new chips are needed from scratch. So yeah, generally actually, a lot of this requires a hardware modification. So all the latest iPhones since the iPhone 14 with Globalstar provide that feature. For Samsung, they only introduced that in the Samsung S25 with the latest Snapdragon chipset, which supports Snapdragon satellite and is verified by Skylo. Same with the kind of Google Pixel 9 as well. So that list of smartphones that support that feature are listed at the bottom of the GSA report. But yes, a new hardware modifications, the latest Release 17 chipset and modem is required for able to provide satellite services, which means the adoption is currently quite premium at the moment in the kind of premium flagship tier of smartphones, but will potentially trickle down over the coming years and months as we see more preservation of these features.
Mm-hmm. I think that's pretty much all our time. So we'll pass back to Richard.
Great. Thank you very much, guys. And thank you for all the questions. I will actually just take one question. Myself saw a question there on recent tie-ups between satellite players and telco operators. Well, that is actually something that is covered in the report, in the members report. There is an annex which includes operators, satellite partnerships, going through listing all the operators, the constellations, their deployment status and use cases. So if you are a member or an associate, then please do download the member report and check out that annex. If you're not a member or an associate and you'd like access to that data, please do get in touch and we can explain how your organization can become a GSA associate. With that, I'll draw today's events to a close and thank you and our research team again for joining us. So you will receive a link to the webinar recording and presentation immediately following this event. Any questions we didn't get a chance to answer, and we had more questions, I think, than we've ever had for any topic, we'll endeavour to answer via email. So thank you for all those questions. Our next event will focus on 5G RedCap. And we'll also, during that webinar, be sharing news about the GSA's new RedCap's Marketing Special Interest Group and how you and your organisation can get involved in that. A link to register for that webinar, again, will be shared with you immediately following this event. Access to all the data behind these GSA reports and webinars is available to all employees of GSA member and associate organisations. So again, if you'd like to get access to that, please do get in touch and we can explain how you can become a GSA associate. For the latest updates on our reports and events, follow us on our social channels or register for the regular emails from our website, and the latest reports will be delivered straight to your inbox along with our monthly newsletter. Finally, I'll just once again say thank you to our research team and for you for joining us today, and we hope to see you at another event soon. Many thanks.
Cheers.